Good trig stuff to know. Okay, I'm going to start off with some formulas, then we'll talk about the unit circle. We know that sine squared x, theta, t, whatever variable I want to use, doesn't matter as long as they're the same. So let's go ahead and use theta because it's more generalized. Sine squared theta plus cosine squared theta equals 1. You need to commit that to memory. Okay, that's going to use it all the time. Now there are two other ones that look very similar. I don't know them, but it takes me just a second to find them. If I memorize something, I've told y'all I screw it up. So I know sine divided by cosine is tangent. So if I divide each one of these by cosine squared, sine squared divided by cosine squared will be tangent squared, right? Cosine squared divided by cosine squared is 1. 1 divided by cosine squared is secant squared. So we came up with the next one, right? I also know I can divide by sine squared, right? But if I do something to one piece, I have to do all of them. So divide every single term by sine squared. Sine squared divided by sine squared? 1. Cosine squared divided by sine squared? Cotangent squared. 1 divided by sine. Cosecant squared. Okay, you need to know those. You see that if you know the first one, you can find the other two. Is that okay? So this is the one you need to memorize, and you can derive the other ones. This one's also very important. Sine of 2 theta is 2 sine theta cosine theta. You need to commit that to memory. Guys, hush. Cosine squared theta is 1/2 plus 1/2 cosine 2 theta. Sine squared theta is 1/2 minus 1/2 cosine 2 theta. You need to commit these two to memory. Notice they're the same. The cosine is positive, though, the middle term. Your book actually writes this one as cosine squared theta equals 1 plus cosine 2 theta over 2. Do you see that I can break that up into separate fractions if I want to? Does that make sense?
For sine of 2 theta equals cosine theta cosine theta, does that work with any, like instead of 2, we work with 3?
No.
Just.
Okay, so you need to memorize these with stars. Okay. We're going to come up with cosine 2 theta. I think there's 3 of them. I don't know them. You can see that these are the 4 I've started, the only ones I know. Okay. But do you see that if I take this second one right here, I can solve it for cosine 2 theta? Okay, so I'm going to do that over here. I want to solve. I'm going to try to solve for this. So I can multiply both sides by 2. So 2 cosine squared theta equals 1 plus cosine 2 theta, right? See that? Okay, and then I want to solve for this, so I subtract 1. So I know that cosine 2 theta equals 2 cosine squared theta minus 1. I don't know that one off the top of my head. I can never remember if it's 2 cosine squared minus 1 or 1 minus 2 cosine squared. I always flip it because there's another one that's the other way around. So do y'all see I just came up with that one off of manipulating this one? Okay. I'm going to take this one and I'm going to modify it as well. I know cosine squared theta can be rewritten as 1 minus sine squared theta. Is that true?
Yes.
So all I've done here is made a substitution. Cosine squared theta is now 1 minus sine squared theta. You see it? So this is 2 minus 2 sine squared theta minus 1. Just distributed this. Michael, do you see it? Okay, so 2 minus 1? 1. See, I never remember which one is 1 minus and which one is the function minus 1 because they look very similar. Y'all see that? You can memorize them if you want to, but it's very easy to screw them up. To flip a sign, do them in the wrong order or something. Just takes a second if you want to come up with it. And there's one more. I'm going to take this original one again. Cosine 2 theta is 2 cosine squared theta minus 1. But this is equal to 1, isn't it? So I can replace 1 with the sum of these guys. Okay, well, let's leave the positive one first if we can.
Cosine squared theta minus sine squared theta is equal to cosine 2 theta.
Okay, so open the front cover of your book. And double check and see if we got them. There's like a reference page. I think it's the back side of that first reference page. They're sort of at the bottom. Again, this one is written as a fraction. It is not in there? It could be on the back of that thing here.
Addition of subtraction formulas.
So this one, I have this one. That is the second, third, and fourth stars. And then here's somewhere. Here, there. It says double angle, and half angle. That's what we just came up with. You see that? I think one of your quiz questions uses the sine 2 theta. It asks you something about sine 2 theta, or sine 2x equals sine x, or something. It's solved.
Is there some sort of rule to the way you're doing this, or you just have to look it up in like reference material?
You have to. These are trig formulas you will use a lot.
Okay.
And if you memorize the 4 with the stars, you can come up with the others. We're going to use these over and over and over again. And over again. And again.
Oh, so I have to learn this one.
And over again and again.
Overjoyed.
Okay, so here's the basic formulas you're going to. Is there anything? Let me make sure there's nothing on there that I didn't.
So do you get the tangent of 2 theta? That's what it is.
I don't even write that one down because I can find it. What I would do is I find the sine 2 theta and then I find the cosine 2 theta. I wouldn't do it that way. I would have separate. I just put that one and see that on this. So those are the major ones. So can everybody familiarize yourself with these and come up with them if you needed them?
I'm trying to get as far as to know what I'm trying to figure out here.
That will come. At this point, where I'm just trying to give you the foundation, you'll see where it's applied in a little bit, when we're ever going to use this.
Like I'm not even at the point where I can ask a question.
Okay, so you have to be able to know these identities. Maybe it's not clear when you'd use them, but we will use them. You need to be able to come up with them, and then we'll have the opportunity to use them. Okay, so this is my scratch work. Here are the ones you need to know. Everybody good? Okay. Let's talk about the unit circle. Okay, if you think about it, guys, hush. The unit circle has radius 1. That's what unit means. It's centered at 0, 0. Actually, I'll draw you a beautiful circle. Pretend that's a circle. More like an oval. Use your imagination. Okay, and all of the points in the unit circle, remember this is the point 0, 0, and the radius is 1, right? So what's this point right here? 1, 0. Does everybody see that? What's this point right here? This one? This one?
Negative 1, negative 1.
Nope.
1, 0, negative 1.
Okay. So those are all the, like when we graphing it, and I told you to do the major tick marks, these are the major tick marks. I have 0, pi over 2, 3 pi over 2, and 2 pi. These are all the places where sine or cosine will be negative 1, 0, or 1. Okay? And anytime you have points on here, they go cosine, comma, sine. Cosine, comma, sine. Cosine, comma, sine. They're alphabetical. That's how I remember them. Okay?
Didn't you miss pi?
Oh, I wrote. Yes. Thank you. Pi, 3 pi over 2, and 2 pi. Okay.
So
Was I paying attention?
the point 0, 1 is pi over 2?
At pi over 2.
Okay.
Okay, what angle is between 0 and pi over 2? Pi over 4. And if I were to extend this line, what line is that? I draw a line through here. Y equal x equal y, right? So that means the x and y coordinates will be the same. Okay? So this point is going to be root 2 over 2, root 2 over 2. Because if I square this and add them up, I get 1, right? You'll see that? You get 2 over 4 plus 2 over 4. You square them and add them up. Okay? So let's just look at the pi over 4s for now. Do y'all see this is 0? Pi over 4, this is 2 pi over 4. This one is 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Yes? Okay? So if this is 3 pi over 4, again, they aren't quite lined up, but you get the idea. I know the points are going to be the same numbers, but I may have different signs, right? So I'm going to have root 2 over 2 and root 2 over 2, but what signs will I have? A negative and a positive? Do you see that? Okay, and down here, I'm going to have root 2 over 2, root 2 over 2, and I'm going to have what signs? Both negative? Because the x value and the y value are both negative. Down here, 7 pi over 4. Again, these guys match. And the signs are going to be positive, negative. Do we understand this? So can you fill in the unit circle? We'll have all the pi over 4s. Okay? Now let's ignore the pi over 4s. And we're going to do pi over 6 and pi over 3. So let's go ahead and fill in the whole circle with the angles, and then we will fill in the points. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 is, this really is, I'm cramming it all together, 2 pi over 3, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6 is 5 pi over 3, and what's this? 11 pi over 6, and you check yourself, this one is 12 pi over 6. Do you see how you count it out? Okay. Now, remember, I'm really thinking about, I'm using, the unit circle has this equation. X squared plus y squared equals 1. So the x value squared plus the y value squared has to equal 1. So if you look in Trig, they actually derive it probably, but we're going to see that 1/2 and root 3 over 2 are buddies. If you square them and add them, you're going to get 1. Is that true? Check it. Is that true? 1/4 plus 3/4? Okay. So here's how I remember it. Pi over 6 is root 3 over 2, comma 1/2. These guys always go together. They're buddies. They always hang out. But 3 times 2 is 6. So that's the one that's in front. You see it? Pi over 3. 1 plus 2 is 3. Its buddy goes in the back. You see it? Okay, so even looking at 2 pi over 3, I could just reflect this. But the way I would do it is say there's a 3 on the bottom. It's reduced. You always make sure it's reduced. It's reduced. There's a 3 on the bottom. I know the front's a half. The back's root 3 over 2. And then I check the sign. Sign should be what? Check it again. Negative and positive? 5 pi over 6. There's a 6 in front. So don't worry about the sign right now. But what should the number be? Root 3 over 2, comma 1/2, because 3 times 2 is 6. This is reduced. So the sign should be negative and positive. Okay? 7 pi over 6. 3 times 2 is 6. So this one is negative, negative, actually, right? Let me write that again. Does this make sense? 4 pi over 3. What should the point be? 1/2 and root 3 over 2, and then tell me the signs. Negative and negative. Okay. 5 pi over 3. Negative 1/2, or sorry, 1/2. Let me do the numbers first. 1/2. Root 3 over 2. Signs are positive and negative. 11 pi over 6. Okay, and the sign should be positive and negative. Okay. So one of your quizzes, I think it's already posted on the quiz page, is I will give you a blank piece of paper and you have to fill in the unit circle. Just like I did here. I don't want any angles in degrees. I just want them listed in radians and all the points. Okay? And the unit circle quiz is the only quiz you can take until you get it perfect. So I'll give it to you one day in class.
So
Some of you are going to nail it. Hang on a second. Some of you are going to get it. Hang on. Some of you are going to get it all right, and then if it's either all or nothing. If you miss anything, you flip a sign, or your 3-2 looks too much like a 2, whatever, then you get to redo it because it's good practice. And you may have to do it outside of class, even before class or class. I'm going to give you a blank piece of paper, and you're going to draw this. You're going to label all the measures. Yes.
is pi over 4 the equivalent of 90 degrees?
Pi over 2 is the equivalent of 90 degrees.
Okay.
But remember, pi is equal to 180. Because if you were looking here, okay, if I go all the way around the circle, I'll do a 360, right?
Yeah.
Well, 360 is 2 pi. I go all the way around the circle, that's the same as 360 degrees. So, but if I start at 0 and go all the way around, I've also gone 2 pi radians. So the conversion is 2 pi radians. Guys, hush, equals 360 degrees. So pi radians is equal to 180 degrees. So pi over 4 will be 180 divided by 4, which is 45 degrees.
Well, is 2 pi radians different from just 2 pi?
The units are radians.
Okay.
A lot of people don't write radians, but those are the units. A radian actually is a length, the arc length from this circle. If you start at 0 and go pi over 6, that's the length of this arc on the unit circle. If it's not a unit circle, then it's equivalent to, you can translate it to an angle measurement. But that's what a radian is. It measures arc length.
So a radian isn't just a radius?
No.
Okay.
It measures arc length. A radian is just a unit of measure that we can compare to a degree measure, like an angle measure, but it technically is arc length.
So a radian of 2 pi would be a circumference.
Radian, if 2 pi radians, we're going to, you get it from coming up with the arc length of the circle, which is a unit circle, is a circumference. But anytime we say 2 pi radians, we are actually talking about like an angle measurement. But it actually comes from the unit circle. It's an arc length on the unit circle.
Okay.
But we were always going to use it as an angle measurement. Does that make sense?
Yes.
Okay. Okay, so if you are, new page. If I wanted to find sine of 17 pi over 6. This is how I do it. I know people talk about reference angles, all that. And there's a lot of good trig there, but I'm going to try to do it as fast as I can because when it gets to calculus, this is just going to be a tiny bit of my problem. I need to know how to do it. So this is what I say. I say 17 pi over 6, that's reduced. There's a 6 on the bottom. So I know automatically my point looks like what without the signs? Root 3 over 2, comma, 1/2. This is sine. Cosine, comma, sine. My answer will be 1/2 or negative 1/2. Right? That fast. We're just going to take a second and decide if it's positive or negative. Okay? So another cool thing you need to remember about trig is, hang on one second. Have y'all seen this? Do we know, who's never seen this? Okay, this stands for, okay, let me tell you, I read it as AX because that makes sense to me. The way your book says it is all students take calculus. That's ridiculous. Not everybody takes calculus. So all students take classes is okay with me. Okay. All trig functions are positive here. That A stands for all. S means sine and 1 over sine are positive. Because it's reciprocal, it has the same sign as it does, right? Tangent and 1 over tangent is positive in quadrant 3. And this C means what? Cosine and 1 over cosine are positive, okay? So you're going to use this all the time. So going back to this one, we still need to determine the sign of it. I need to know where 17 pi over 6 is. Okay, so what I'm going to do is I'm going to kind of think about what I have here. And you're going to start to realize that if I go around and I get 0, this is pi. This is 2 pi. This is 3 pi. 4 pi. 5 pi. Do you see the pattern? Can I stop? Can I stop?
Yes.
Okay, what's the pattern? All of the even ones are here. All of the odds are here. So I could, when 2n times pi is over here, even. And then 2n plus 1 times pi's are all over here, odd. Okay? So I want to compare 17 pi over 6 to some whole number that can be reduced. I'm going to use some fraction in terms of 6's, but I want it to be reduced to a number times pi. So what's the closest number to 17 pi over 6 that can be reduced to a number times pi?
18 pi.
So if I have 18 pi over 6 minus 17 pi over 6, I have pi over 6 remaining, right? What is 18 pi over 6?
2 pi.
How much?
2 pi.
3 pi.
3.
Okay, so that means if I go around, I might go around multiple times, right? But if I want to go to 18 pi over 6, I'm going to end up right there, where 3 pi is, right? Went over a little bit. I'm going to end up right here. But I don't quite go there. I'm actually going to be a little bit short. I'm actually going to go and stop right here. So all I really need to know is what quadrant am I in. So I'm in quadrant 2. There's an S there, so it's a plus. S means sign is positive there. Does that make sense? So what about tangent? 19 pi over 4. I know right away 19 pi over 4. Root 2 over 2. Root 2 over 2. Again, I'm not worried about the signs. So tangent is what over what? Sine over cosine. So the answer is going to be 1 or negative 1, right? So I'll plug in the sign in a second. Then I need to figure out where 19 pi over 4 is. What's the closest multiple of 4 that ends up being a whole number? 20 pi over 4 minus 19 pi over 4. Pi over 4 remains. 20 pi over 4 reduces to 5 pi. So I would start here and end up here, but I actually don't quite get there. I actually get right here. So I'm still in quadrant 2. I don't know why I keep picking those. So in quadrant 2, there's an S. Tangent will be negative. Does this make sense? So you can go into a lot more detail. I just want to get, those are basics. Anything else I need to talk about with trig?
We'll just work with, is there a quick way of like if your denominator is like not 2, 6?
We don't know the ratio, you'll have to use a calculator. If your denominator is not one of the 2, 3, 4, 6, then we don't know the ratio. So, okay? Okay, so let me save this. That is trig in a nutshell. I think I got it all. Do we feel a little more confident? Maybe?